Hey class, Mrs. Anderson here. Today we're going to start Unit 3.1 out with factoring. So factoring is a review for some. You've done a little bit of factoring in Algebra 1 and a little in geometry. But it is kind of a confusing topic because it really requires you to know your multiplication facts and kind of think backwards, which can be challenging. So it requires a lot of practice until you kind of catch on. But first, I just want to review. We're going to review FOIL. Do you remember the acronym FOIL? It means first, outside, inside, last. So that's like if you have the binomial like x plus 2 times x minus 4. And FOIL helps us multiply this out because first means you take the first two and multiply them, and x times x is x squared. Then you take this outside and you multiply those. X times negative 4 is negative 4x. 2 times x is 2x. And then the last is the 2 times the negative 4, which is negative 8. And then you can combine the negative 4x and the 2x and give you negative 2x. And this becomes our trinomial. It's 3 terms. And it's a quadratic because it has a degree of 2. And we're going to go backwards now. So factoring, you start with the trinomial and you want to get back to the factored form, which is with the two factors, looks like that. And so that's what we're going to practice today. I'm going to teach you to go back and forth just like that. I'm also going to show you the box method, which works for those of you that are more visual learners that maybe have a hard time just thinking about the numbers in your head and need something more concrete to work with. The box method looks like this. This is a 2 terms times 2 terms. So you make a 2 by 2 box. It's kind of similar to lattice, but multiplication, but you do like x times x and 3. And x and 5. So it's x plus 3 and x plus 5, so it's a positive 3 and a positive 5. Then you multiply rows by columns like this. So x times x is x squared, x times 3 is 3x, x times 5 is 5x, x times 5 times 3 is 15. Then you combine your like terms, you get x squared plus 8x plus 15. And so that is multiplying with the box. Then factoring with the box, well, you say to yourself, what do I have to multiply to get 15, but it has to add up to 8? So basically, I know that I'm going to have my x squared term right here, and I know that my 15 term goes right here, and then I know the middle two have to add up to 8x. So what multiplies to 15 and adds up to 8? Well, 3 times 5 is 15, and 3 plus 5 is 8. So then I know that I'm going to have a 3x here and a 5x here. They add up to 8x. Then you can go ahead and figure out the outside of the box. So like x squared is x times x. Then to get 3x here, you need a 3. To get 5x here, you need a 5. And then 3 times 5 is 15. So that gives me the x plus 3 and the x plus 5. So the box just helps me organize it so that I can visually see which pieces I'm missing. Essentially, you're taking the greatest common factor out of each row and column. We're going to talk more about the greatest common factor later in this lesson. Okay, so let's just start by factoring the simple cases. This is when our a equals 1. We're talking about standard form here, so we're talking about trinomials in standard form, which is you have like an ax squared plus a bx plus a c. So that's in standard form. So this is when a equals 1, which means my leading coefficient is 1 out here. So what you're going to need to do is find factors of c, the 9, that add up to negative 10. So two numbers that multiply to 9 but add up to 10. Negative 10. Well, that's going to be negative 1 times negative 9. Negative 1 times negative 9 equals 9. Negative 1 plus negative 9 equals negative 10. So this will factor, because x squared is just x times x, and then it'll be minus 1 and then minus 9. And then you can always check that by multiplying it back out. X times x is x squared. X times negative 9 is negative 9x. x times negative 1 is negative 1x. Negative 1 times negative 9 is positive 9. So x squared minus 10x plus 9. So it does work, and that's our factored form. So if a equals 1, we find factors of the last number that add up to the middle. So factors of c that add up to b. So factors of 8 that add up to 6. Well, 2 times 4 is 8. 2 plus 4 is 6. So to get x squared, it's x times x. And then to get 8, it's 2 times 4. They're both going to be positive because they add up to positive 6. So this is our answer for the factored form of that trinomial. Quadratic trinomial in this case. So in factoring, you can look for patterns, and that kind of helps you when you're working through these numbers as well. So if you have a number at the end that's positive, so it multiplies to a positive and adds up to a positive, multiplies to positive and adds up to positive means both your factors will be positive. If it multiplies to a positive number but adds up to a negative number, then both of your factors are going to be negative because it's multiplying to positive. So two negatives make a positive product, but it adds up to a negative number, so your factors must be negative. And then you have the other cases, like if it multiplies to something negative but adds up to a positive number, then you're going to have one positive and one negative. If it adds up to a positive, then the positive one is the bigger factor is the positive one. If it multiplies to a negative and adds up to a negative, then one of each, but the negative factor is the bigger one. So that might be a little confusing just without numbers. Let's look down here. So negative 20 adds up to a negative. So multiplies to a negative, adds up to a negative. So you're going to have one positive factor and one negative factor. It's x squared, so it'll be x times x gives me x squared here. And so then you just need to figure out, well, what multiplies to 20, negative 20, but adds up to negative 8? Well, it's 10 and 2, and I know that the 10 has to be negative since my answer is negative 8 in the middle. So I have to have negative 10 and positive 2. If you wanted to put that in the box, if you're more of that visual learner, it would have looked like this. You would have started with the x squared and the negative 20, and then you know that this has to be negative 8x. You use these numbers here to fill in your diagonals like negative 10x and 2x, and then you work backwards to figure out the outside. So xx, negative 10, and positive 2. Same idea, just with just more of a visual model representation of it. So if you have in B over here to the right, you have something that multiplies to a positive but adds up to a negative. That means both of your factors must be negative. So x squared again, so it's going to be x times x. So now you need something that multiplies to positive 50 but adds up to negative 15. So they both have to be negative. That'd be negative 10 and negative 5. Negative 10 times negative 5 is positive 50. And negative 10 plus negative 5 is negative 15. So this is x minus 10 and x minus 5. Remember, you could always FOIL it back out to double check your answer. Throw it in the box, make sure it works out. If you have down here, we'll call this C, example C, multiplies to a negative 16, adds up to a positive 6. So that means it's going to have one negative and one positive factor. Since it adds up to a positive number, the positive factor will be bigger. So what multiplies to negative 16 but adds up to positive 6? So you're looking for two numbers that have a difference of 6, essentially, that multiply to 16, which would be 8 and 2. 8 and 2 have a difference of 6, and I want it to be positive 6, so the 2 is negative, the 8 is the positive one, the 2 is the negative one. They multiply to negative 16, add up to 6. And the last one, if they're both positive, multiplies to positive, adds up to positive, it's going to be positive. Like x plus and x plus. What multiplies to 6 adds up to 5? That would be 2 times 3. 2 times 3 is 6. 2 plus 3 is 5. So those are the factors for that. So those are some patterns to look for when a equals 1. So these are all quadratic trinomials where our leading coefficient was 1. Those are easier because you know it's going to be x times x every time. X times x. So we just need to figure out the second piece. Now, when a is not equal to 1, it makes it a little bit more challenging. But what you're going to do is you're going to find the product a times c that adds up to b. And so remember, it's a, b, c in standard form. And essentially that's what you were doing up here. A times c adds up to b because a was 1, a, b, c. A times c in the top one up here was 6 and adds up to 5. So down here, a is 2, c is negative 6. So you need something that multiplies to negative 12 but adds up to negative 11. So what two numbers multiply to negative 12 add up to negative 11? And I got negative 12 by taking the first and the last one multiplied. So that would be negative 12 and positive 1. Negative 12 times 1 is negative 12. Negative 12 plus 1 is negative 11. So then writing my factors takes a little bit more thinking because instead of just an x, I have a 2x squared. But there's only one way to make 2x squared. It's either 1x, it's just 1x times 2x, or 2x times 1x. There's only one way to make 2, 1 times 2. So you know you have to have a 2x and you know you have to have a 1x. Now the middle terms here are what make the negative 11. So you need to figure out which one or where they go, like how to get negative 11 in the middle, thinking through the FOIL process. So when you take the first one times the last one and the middle ones together, you have to make negative 11. So I know that the negative 12 has to go with the 2. So what times 2 is negative 12? Well, that's negative 6 because 2 times negative 6 will give me negative 12x. And then 1 times positive 1 will give me 1x. And negative 12x plus 1x will equal negative 11x. So that is how you work through that and get your answer. So your answer is 2x plus 1 times 1x minus 6. If you throw this in your box, for those of you that really like that more visual representation, it's going to look like this. You're going to put your 2x squared right here. That's your first term. Then you know your negative 6 goes in your last box. And then you want the middle to add up to the negative 11. Whatever you get in this diagonal goes here in any order. So 12x and 1x. And then you figure out the outside of your box. Whoops. By looking at the greatest common factor for each row. So like what do these two have in common? They both have a 2 and an x in common. What do these two have in common? Down here, they both have just an x in common. And 2x times x is 2x squared. Then 2x times what is negative 12x? Well, that's negative 6. And x times 1 gives me 1x. And then 1 times negative 6 gives me negative 6. So working backwards to figure out what multiplies to get the inside of the box. So that gives me the same factors, 2x plus 1 and x minus 6. So that's another way of getting that answer. Okay, let's try this one. So here I have a times c would be 2 times 6 is 12 and adds up to b 7. So I want two numbers that multiply to 12 add up to 7. So on the top it's multiply 2 and this one is add 2. And you need these two numbers. So that would be 3 times 4. 3 times 4 is 12. 3 plus 4 is 7. All right, to get 2x squared, I know I'm going to have 2x and a 1x again. And then you need to think, well, what does the 2x need to go with? I need to get either 3 or 4. So I can make 4 with 2x because 2x times positive 2 is 4. And then that gives me my 4x. And then 1x times 3, positive 3 would be my 3x. And 3x plus 4x is 7x. So that's my answer then. 2x plus 3, and x plus 2. Essentially, you could do that with the box as well. You would put the first term, 2x squared here, the 6 here. You know that this middle part has to add up to 7x. Whatever you get for these middle numbers here, go here in any order. You could put the 3 here, the 4 here, it doesn't matter. Then you figure out the outside by thinking what they have in common. So these two have a 2x in common. Then 2x times 1x gives me 2x squared. 2x times 2 gives me 4x. 1x times 3 gives me 3x. And 3 times 2 gives me 6. And then 1x plus 2 and 2x plus 3 give me my answers as well. So the box is just another way of organizing it, thinking through it. Okay, so remember, factoring is the reverse of multiplying two polynomials. So before, we've done stuff like this where you distribute this through, and 5 times 3 is 15, and x times x is x squared. 5 times negative 7 is negative 35x. Foiling, if you have two terms, so x times x first is x squared. Outside, x times negative 5 is negative 5x. Inside, 6 times x is 6x. And last, 6 times negative 5 is negative 30. Combine your like terms here, x squared, it'll just be a 1x minus 30. So that's what you've learned before, multiplying it out. Now today, and now we're reversing it. So now you're thinking, well, what can I divide both 15 and 35 by? Well, I can divide both of them by 5. What can I divide x squared and x by? The biggest x I can take out is an x. So if I divide both of these by 5x, what's left? So I take that 5x and move it out front. And here I'd have 15 divided by 5 is 3. X squared divided by x is x. Then 35 divided by 5 is negative 7, and x divided by x is x, or 0, or 1. It's 1. It simplifies to 1. So factoring is just the reverse. You're dividing, essentially, and you're putting that the number that you divided out front. And then in this one, you're saying, well, I know that x squared is x times x. Then what multiplies to negative 30 but adds to 1? Well, I know it's going to be 5 and 6, and then if it adds to positive 1, the 6 is positive and the 5 is negative. So we're just kind of going back and forth between multiplying it out, and then factoring is going backwards. So the greatest common factor is the largest factor that all terms have in common. What is the biggest thing that you can divide everything by? Evenly. So you need to divide evenly. Divide it out evenly. Okay, so I like to look at my numbers first. If I'm looking for the GCF, between 4, 2, and 6, my GCF will be 2. I can divide them all by 2. That's the biggest number I can divide all of those by. Now, x cubed, x squared, x. X is the biggest one that I can take out because that's the 6 only has 1x. The 4 has 3 x's. The 2 has 2 x's, but the most amount of x's I can take out is 2. Essentially, then you're dividing all of these by that 2x when you pull it out. So then you can reduce this and you're going to get 2x squared. So you took 1 out, so there's 2 left. Then you're going to get negative 1x. There's 2, you took 1 out, there's 1 left. And then you're going to get negative 3, 6 divided by 2. Here you took away all the x's, so that reduces to 1. So it's just 3. You could multiply that back out to check your answer as well. For 6y plus 3y squared, 6y to the 4th plus 3y squared, you can take out a 3 because that's the biggest number that both 6 and 3 are divisible by. And you can take out a y squared because the 3 has 2 y's, this one has 4, so the most you can take away is 2. So if you take the 6y to the 4th and the 3y squared, you divide this one by 3y squared, you're going to get 2y squared. So you take away 2 of the y's, 2 are left, and 6 divided by 3 is 2. Take this one, 3y squared divided by 3y squared, that's going to equal 1. Remember, anything divided by itself equals 1. You can always multiply this back through to double check that that is in fact the correct answer. Then this one, between 3 and 12, I can divide them all by 3. I can't take out any x's because the 12 doesn't have an x. So then this is going to divide this by 3, divide this by 3. It's going to be x squared minus 4 left. And then actually, this can factor more because if I think of negative 4, because I have ax squared plus bx plus c, so a is 0, or a is 1, b is 0. So what multiplies by negative 4 and adds up to 0? That's negative 2 and positive 2. So this one does actually multiply or factor out one more time as x minus 2 and x plus 2. Because in the middle, you would get that 0x, and it would multiply to positive and negative 4. So that's actually called difference of squares. We're going to look at special patterns tomorrow, but that is one thing to notice. If you have like a perfect square and you're subtracting, you can factor it further. Last one is just greatest common factor one more time. You can take out a 6. Oh wait, you can't take out a 6. You can take out between 6, 15, and 9. They're all divisible by 3. And you can take out an x. So if I take out a 3 and an x, that's going to leave me with 2x squared there. 3x from here is going to be minus 5x. And a 3x from here will be minus 3. So let's just see if we can factor that any further by taking a times c. So negative 2 times 3 would be negative 6. That multiplies to negative 6, adds up to b, which is negative 5. So I can find factors of negative 6 that add up to negative 5. That's negative 6 and positive 1. So this does factor further. I know that I have a 3x out front, and then to get the 2x squared, you have to do 2x times like 1x. And then to get the negative 6, I can use the 2, because 2x times, you could say 2x times negative 3 gives me the negative 6x. And then to get the 1, you do 1x times, I just need a 1x here, so 1x times positive 1 gives me 1x. So then this would be your final answer, and it's factored all the way. So you had to factor the greatest common factor out, and then I checked to see if it could factor more, and this kind of told me that it could. So there you go, day 1 of factoring. There is multiple ways to do this. If it didn't make sense to you, try looking up a different video and see if the way someone else explains it is better. Ask a friend, ask a different teacher, ask me. I have a couple other methods I could show you. It really just takes practice. The more you practice, the easier it will become. We will factor the rest of the year, so you have to buckle down and commit to learning it now. It's only going to help you in the future. All right, thanks for watching.